Hello, this is Keith Graham from Codasip. In this video, Assignment 2, Checkpoint 2, writing your routine in RISC-V assembly, I like to go through the basic process flow of actually writing that routine. That process is almost identical to the C program, where you declare a variable, you initialize it, you do a for loop, and within the for loop, you execute the algorithm, and at the end, you do a printf of the result. The one big difference in the process, instead of a printf at the end, you will just be storing it into memory. Now let's take a look at the first step, declare, or what I also like to call planning. Now at the very top of your assembly routine, which you will be doing in assembly_abstraction.s, once again .s signifies an assembly program, is you want to declare or make a note of all the different registers and what those registers are used for. So that you'll be going or referring back to this throughout writing your routine. So you know, like for example, which register am I using for the loop counter? Which register am I using to store the result? So there's three basic types of registers that you will need to store for this assignment. Registers that are related to your loop, registers related to your algorithm, which is inside your for loop, as well as the address that you're going to store your result to. Now, a very helpful part of the Assignment 2 document is Appendix A, which describes all the assembly routines or functions that are supported by the model that you have in your workspace, the IA_RISC32i. So please refer to this if you have any questions on what the assembly format for any of these operations looks like. Now, after we declare or plan our variables, the next thing to do is to initialize. You might ask, which ones do I initialize? I believe it's always best practice to initialize all variables. So some variables you will know what you need to initialize, because like for example, a result, you might need to initialize that as a 0 to start with, or some value, for example, max count for your loop. Now let's take a look at how we would do that. The best operations to use to initialize a variable if it's less than plus or minus 2048 is an immediate operation. The reason why it's plus or minus 248 because the immediate is a signed operation in RISC-V. Now, if you take a look at this first routine, it's x5 is the result register of x0, which is always 0, plus the immediate value of 0, so the result is 0. So the nice thing about RISC-V, we have a operand which is always defined as 0, which is x0. So then you can just put whatever you want to initialize it as the immediate value. Now on x6, which is my max count of my loop operation, it'd be x6 equals x0, which is always 0, plus the immediate value of my max count. So x6 will be my immediate or my max count. So sometimes you have to store or initialize a number greater than 248. For example, a lot of times when you are creating an address to store a result to, it will be greater than 2048 hex or decimal, and therefore you will need a different way of doing it. There'll be another video available to show you how to do that on the frequently asked questions playlist. Now, let's take a look at implementing the for loop. The best way to implement the for loop is first to create a label at the top of the for loop, because that's where you will always branch to. Now, a label is a word with colon at the end that will signify the linker to calculate an address that you can branch up to. Now, after you've created the label, the next thing to do is implement the algorithm using the RISC-V instructions that you can find in Appendix A. Now, I got my algorithm. I can implement my algorithm. And then after I implement my algorithm, I need to update my for loop counter, because I got to count how many times I'm going to go through this loop. Then after I increment that, which is always an easy way of incrementing is using an immediate operation, such as add, where the immediate value is 1, is to compare it to do a branch. Now, if I'm branching up to the max value, As long as my for loop's not equal to the max value, I'm going to branch up. So if it's not equal to my branch value, then I'm going to branch up. But once I equal to the max value, I don't want to branch, and I will continue on down. So you need to decide exactly how you're going to implement the branch operation. Now, after I've done my for loop, I have to store the result. And so once again, please look at the appendix on how that is actually implemented. But for a shortcut here, I have it, I've written it up here, which is store RS2 register, which is going to be your where the result is. And then there'll be an immediate, which is offset to RS1, which is the value of the address that you are going to be writing to. So after the for loop, you're going to have, depending upon the assignment, a couple, 1 or 2 or 3 maybe results that you need to store into memory. And after you store the values into memory, you're going to want to halt the program. So basically the format is declare a plan, initialize, do the for loop, store the results. And once again, at the very end, you actually do have to add the instruction called halt so that the simulator knows to exit the simulation. Hopefully this video helps. If it does, please subscribe to this channel so that you will be updated when future videos are published. Have a good day. Bye.